In this lesson we're going to look at chemical tests for anions. Okay, so anions are negative ions, and first of all we're going to look at the carbonate ion, and we remember that the formula for the carbonate ion is CO3 2-. Okay, so let's imagine that we've got a solution of carbonate ions here, and this could be, for example, sodium carbonate, potassium carbonate, copper carbonate, calcium carbonate. It doesn't really matter. All we want to do here is identify the carbonate ion. Okay, so for our test solution what we're going to use is diluted hydrochloric acid. Okay, so using a pipette we're going to add a few drops of dilute hydrochloric acid to this test tube. We're going to put the bung in place, and then we're going to observe that after a while that a gas is released, and that gas is going to be passed through lime water. So you'll notice that as this happens, the lime water turns clarity white, which tells us that the gas being released is carbon dioxide. Okay, so there we have the first test. The test for a carbonate ion is to add dilute hydrochloric acid, and as a result carbon dioxide will be released, which can be detected using the lime water test. Okay, the next anion that we're going to look at is the sulphate ion. Okay, remember that the sulphate ion is SO4 2-. So again here we have a solution of sulphate ions. Again, it could be sodium sulphate, potassium sulphate, doesn't matter. We're testing the anion in this case, and so to do that our testing solution this time is going to be a mixture of barium chloride and dilute hydrochloric acid. Now the key substance is the barium chloride. I'll explain the dilute hydrochloric acid in a minute. First of all, what happens when the barium chloride meets the sulphate ions? Well, a white precipitate will form. Okay, that's not very clear, but that's a white precipitate. PPT stands for precipitate of barium sulphate. So if we look at the equation for this, then we can see we have barium chloride will react with the sulphate ions, SO4 2-, to give us barium sulphate. That's the precipitate, so a down arrow for precipitate, plus Cl-. Let's do that. AQ, that means in solution. These ions are in solution, and so the chlorine ions then go into solution, and we get this white precipitate of barium sulphate. Now that's not balanced now, so you just need to balance that equation. So we're going to put a 2 here, and you'll see that both the charges and the atoms are now balanced in the equation. Now why do we add the dilute hydrochloric acid? Well, when you initially form this solution of sulphate ions, you're mixing a salt with water and stirring it around so that the salt dissolves in the water. Well, typically that water may contain other ions, particularly the carbonate ion. Likewise, the barium chloride solution may also contain carbonate ions or sulphite ions. So by adding dilute hydrochloric acid to the solution, that will then remove the carbonate ions, either from the testing solution or also from the solution that you're going to test. So this basically makes sure that there are no carbonate ions or sulphite ions present in the solution, so that we can ensure that the only ion that we're testing is the sulphate ion. So that removes carbonate and sulphite, not sulphate, sulphite ions from the solution. That's CO3 2- and SO3 2- ions. Now I would also like to point out is this technique of mixing the testing salt with an acid in order to remove the carbonate and sulphate ions. Well, notice that you must choose an acid whose anion or anion group is the same as that in the testing salt solution. So because we're using barium chloride with the chloride ion, then we need to use hydrochloric acid because that has the chloride ion too. Right? We could not use, for example, sulfuric acid because that would introduce sulphate ions into the solution, which is exactly what we don't want if we're testing for sulphate ions in our test solution.